Our PhD student, Mr. Srinivas Karthik from Database System Lab, and he will be giving a very interesting demo on big data small testing, and it's going to be very interactive and ask a lot of questions. You will have enough scope to answer a lot of questions as well, so there will be a lot of prizes. So go for it, and let's thank Srinivas Karthik again, and I'll request him to start this talk. Thank you.
Thanks for the kind introduction, Adirupa. So let's see. Okay, I think some of you have been here for quite some time, around 10 minutes or so. You have been seeing this slide. So what's your guess? So we are starting with the question again. Okay, let me not come in the way. One guess, one. I hope the lunch was not too bad or too good, sorry. One. Sorry? Right. So essentially we have a dumbbell here. Mr. Smart is essentially giving an impression to the whole world that he has actually picked the whole dumbbell. And if you call this as two dumbbells, and so essentially, yeah, so we have tested his muscle power. Okay, let's see what it is in the future. So how many of you know what a database management system is? Okay, how many doesn't know what a database management system is? Okay, I'll try my best to keep you occupied, but essentially database management systems are essentially used for storing mainly enterprise data, wherein they are mainly sort of used to efficiently do certain functionalities such as storing data in a very nice manner, retrieving data in a fast manner, and as well as modifying data. So here are the software, popular software packages that are sort of used. These are the commercial ones, like IBM has some, and Oracle SAP has some of these database management systems, while there are also certain open source DBMS engines such as PostgreSQL, MySQL, and so on, which some of you might have heard about MySQL. And so let us see what an relational database is. We saw what a database management system does, which is a software, but this management system works on what is called a database. What is called a database? Here, so again, so some of you, I think most of you are third year students, is it? Okay, how many are second year? Okay, fine. There are at least some 30% or so. So, if some of you want to join IISc, okay. So, what is the first criteria that you look for? No, I mean, say you are gate rank number 1. All of you are gate rank number 1, and so what is the criteria that you look for selecting which of the institutes that you want to join? Sorry. One loud answer, please. Huh? Placements, right? Perfect. So, so I have put this number called as 20 lakhs. I don't know whether 20 lakhs is a good number for you guys, but I would like to see whether that institute, how many students of this institute which I'm going to join or look forward to join has at least 20 lakh salary. Okay. So say that we have the luxury of this IISc academic database, and I want to just, which has certain tables and columns which have all the data that you want, and I'll just make a SQL version of this query. You all know what is SQL means, of course. Okay, fine. So I make an SQL. Okay, what does SQL mean? Great. Okay. And so I may just make a SQL version of this query, and I'll fire it into the database. I'll get some answer because it's a count of number of students. Okay. And the point to be noted here is that say the query that you give is declarative in nature and not procedural. When I mean declarative, you asked the database management system to give your answer of the number of students. You didn't tell how you wanted the students, or what was the path you took, or what is the strategy to get back the results, right? It's like, so most of your C language or Java language, the coding you do, they are all procedural in nature. In the sense, when you say, you don't say just sort the data, right? You say whether you write a code to sort the data, whether it's a bubble sort or a quick sort or a merge sort. There are means of achieving it. That is what you specify in a procedural language or so. But when things are declarative in nature, you just say sort, but you don't worry about how it is done. Okay, that is what is happens in a database, in a relational database systems. So someone has to do the job of finding the best path or best sorting mechanism to fetch the data, right? So let us see what happens when you give an query to a database management system. So essentially there are three components that you have to know when this query is given. Essentially it passes through what is called a query parser. It's like our compiler in our procedure language like C compiler, Java compiler, so on, which essentially checks for the syntax. Okay, and second is what is called the query optimizer. Okay, this optimizer does the thinking part that which we do it for ourselves in the procedural languages or procedural things. So essentially, what query optimizer does is to find a plan or a strategy to fetch the data from the disk and give it to the user. Okay, do everyone understand what is, and that is called as a plan. Does everyone understand what a plan means? It's like, I'll give another analogy. It's like, you want to reach to an airport, to the airport, Bangalore airport from here. You, in the SQL, you have told I want to reach the airport from IISc, okay? But someone has to find we all are greedy. We want to reach in the shortest time possible, right? Given the traffic we have. So someone has to do the thinking for us. What is the path, or someone has to plan for us the path that we take to reach the airport. That is done by the query optimizer, okay? And essentially, all those who understand, for instance, there is a node in this is a tree. This can be treated as a tree, and there is a node for every predicate. So this is for the join predicate, and this is for the base predicate. Okay. So the thinking part is done by the optimizer, which essentially we expect that the plan or the strategy that query optimizer gives will take the shortest time to for the query to process and give back the result to the user. Okay. So, and finally, this plan or strategy is given to the query executor, which essentially executes the query in the manner that has been told by the query optimizer. Fine? Okay, great. So the point to be noted here is that this plan is chosen based on a set of statistical metadata. So I'll say in the next slide what the metadata means. So just keep in mind that the query optimizer uses the statistical metadata to get the plan or the strategy. So an example of a statistical metadata is something like this. So here is the next question. So now we want to know how many students have actually got greater than, have you all seen histograms? Okay, what is one simple, okay. In TV, there's one scenario where you always see histograms every 5 overs. Cricket, right? So you see in 1 to 10 overs, you say 100 runs or whatever it is. You keep seeing that. So essentially, they are the histograms. So here, essentially, salary, sorry, here salary are represented by the x-axis and the number of students with the y-axis. So how many students have greater than or equal to 20 lakh salary? Can I tell this? Huh? Okay, so which means that from the green bar to the purple bar, whatever the height is, I just want to add all the heights, right? Fine, great. And so this is what the query optimizer does, and it essentially estimates the the number of tuples that are passing through this criteria, which is essentially the sum of all this. Okay, and this is a very simple scenario. I'll come to a now. Here's the second question that I wanted to ask: what is the salary for this? Greater than or equal to 20 lakhs, less than 25 lakhs. Is it easy? Hard? What is it? I want to know the correct ones. Query in order to get the right, the shortest time plan. In order to get the best plan, I want to get it right. I want to get these coordinates right. Huh.
For the query, we will introduce one more table, which is that student table, which is having the salary of each student.
No, that is already there in the placements things. Yeah. I have to go to the table, right? No, the histograms are supposed to be coarse histograms, right? If the table is 1 terabyte, my histograms are just in KBs. No, I told you the query optimizer just uses the metadata, just the histograms. I didn't tell it should not use the underlying table. Will that always be right? You are not a bad optimizer, but you may be wrong, right? So that's why the task for the query optimizer is very hard to get the least time plan to execute. You understand the big problem under the query optimization is that to get the statistics exactly right, to get the number of salaries, number of students within this range, to get it perfectly right is very hard. Okay, since these data are sort of representation of the underlying data, and the query optimizer uses this representation to do the analysis. Okay, so yeah, we understand that there's a lot of hard things that query optimizer is doing. So here's the the big picture or the overview of the query optimizer. First, it estimates the coordinates for essentially, for example, the salaries that we spoke about, and the better the estimates are, she told something divided by 2. Okay, that may be right, that may be wrong, right? If it happens to be correct, we actually get a better plan, which implies that it will be better in terms of execution time. It will be lesser execution time. Okay, you get the big picture. Any questions until now?
When the query optimizer uses the metadata, could we have the range, the values is lesser if we want from 20 lakhs to 25 lakhs?
Yeah.
The range should be 0 to 5 instead of 0 to 10.
It can be. It can be anything. I just gave an example. Right. So, okay. Any more questions? Yeah, please.
What those metadata only? What creates which part of
the optimizer itself has several components which will see the sort of when you load the data, it will actually get the metadata information.
So basically, this histogram is not already present as a metadata in the system.
Of course, no. If you change the data, even that will change.
So the optimizer also has to get the plan to get that particular data. It has to plan that it has to get a histogram.
No. First, it will have the histogram. In order to get a plan, it uses this metadata because it has to estimate the coordinates, right? How many tuples will pass through that whatever 12 between the 20 lakh to 25 lakhs.
Depending on the query part, it just train all that data first and then
Then it's already done, right? You already got the data. You want it in the fastest possible manner. Okay. Yeah. Sorry? How will you create? Okay, so basically there are techniques for it. So I'll take that offline because we have certain other things to do. No, if you go to the data, you can rather execute the query itself. You would have got the answer by the time. So you want, finally, this plan is essentially a strategy to get the results from the disk, right? If you want to go to the disk, why you need all these things?
but then we have to go to the disk.
Fine, but the point is you want the best strategy which will take the least amount of time. The strategy is chosen by the optimizer. That is based on the estimates.
That's using the metadata. I have to do the
Strategy?
relating to the disk
Yes.
so that I can
Yeah, and ideally you want the best strategy which takes the least time. Yeah, true. Yeah, right. Okay, so we'll move on. Thanks for a lot of questions. Okay, so now the point is, see, these database systems we all use it. In fact, all the relational, all the financial companies use a lot of these things. But now the data are increasing huge, right? We all know the word big data, right? So now your company manager, we have a database system here, and he says that tomorrow I'm getting a yottabyte of data. What is yottabyte of data? How much data it is? How much? No. 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 Sorry? No. Okay, so in the interest of time, it's 10 part 24 bytes. 10 part 24. Okay. So he wants to test your whether your optimizer or your database system works for that much amount of data. Okay. So now what you do, you go and you'll create 10 part 24 data, yottabyte of data, and see whether it works. That's the natural thing to do. But do you have the time to create? Do you have the hard disk? Do you have the resources to create such? Of course, no. But you always get tired because of, in fact, creation of data would self-tire you. And a smart person actually, what he does is, he'll just change the metadata to say that it has 10 part 24 amount of data. I can just, without having that much data, I'm fooling the database system saying that by changing the metadata that I have so much of data. Okay, and this is what a smart person does. And now see how your plans changes. Okay, and that's how you can test. So we have actually simulated a big data without having that much data, right? So can we test? Yes, without big data. To what extent is, of course, we cannot test the query executor which actually needs the data, but what we can actually test whether is the query optimizer doing a good job or not. Okay, so what we constructed, what we did in our lab is essentially what is called as building a software called as CORD, which is essentially called as, which is essentially a metadata processor, which has three features called as metadata construction. If you say that your database system does not have the correct metadata, you can actually go and construct it yourself using this software that we have. And say you have two database engines where one does not have the right metadata and the other has a nicer metadata, you can actually port from one engine to the other. And the third one is what is called the metadata scaling. That is the 10 power 24 scenario that you can simulate using this feature. So I'll just quickly see the demo for this. So essentially, the first feature says that you can actually create the metadata to your liking in any database system, okay, and that you can do using this CORD software. Let us see how it is. So this is a CORD software, okay. First, so you can sort of choose the Oracle database and say you connect. This is a CORD software, and you can select certain tables that you want to change the metadata for. And so let us say that you want to create the data metadata for your liking. And so here is so you have the table customer, and now you actually can give the cardinality of the customer table to your liking. Now it has given -23, so it has a nice if you give bad values, it can detect for itself. If you give a string, so what it will give now? Again error. So you cannot have a string cardinality, right? This is the number of rows for the table. So now you can give whatever value you want. And so for this table, you can say these are the number of rows it was, and these are the number of pages in the hard disk it's taking, and you can also give the length of the each tuple, okay, and you can update the metadata statistics. So these are the statistics that that will be contained in the metadata for each table, okay, number of rows, number of blocks, average, what is the size of each tuple, and so on. So you should here you can also give the number of distinct values, for instance salary, and it should not exceed the number of the cardinality, right? The number of distinct cannot exceed, so that's why it gave an error again. So you can give all these features. For instance, you can give the density as well. And you can also specify the histogram type. There are several types of histograms. And you can actually tell what are the values that you would like to have in this histogram. Okay, and we have actually put that, and here are the values that that histogram will have. Okay, and then you can show the graph where this is the histogram that we'll be looking for, where so this is a histogram of the buckets that you created. Okay, so here the values are ranging from -1000 to 10,000, and here is the frequency count. Okay, and now you can change to your you can actually widen each of these buckets. Buckets essentially represent a range, saying that from range A to range B you have this many number of tuples. You can change it, you can add you have the next one. So you can also add a bucket if you think that you would like to have. For instance, we also saw that case where the metadata was not coarse enough to capture between 20 lakhs to 25 lakhs, right? So you can actually add a bucket in between that, so that you get the exact count. So all this can be done. You can also merge two buckets from 20 to 40. You can merge two buckets and so on. So these are all done by the our CORD software, and so this is a second feature where essentially if you think that the metadata in the second database engine is not good, you can actually transfer from one database to the other database. All these things can be done, and the nice feature is the scale mode feature, where essentially say you have only 1 GB of data and you want to test 1 yottabyte of data. So how we do is essentially we scale the metadata to represent 1 yottabyte of data, and using this CORD software we will see again a demo of how this is done. So this is a size scaling where you want to scale from 1 GB to 1 yottabyte, and we'll see how it is. So say that you have an SQL query which essentially represents, say this query asks for how many tuples are there for each table. Okay, so you have got this, you can just have a quick look at it. So these are the number of tuples for, you can all see this. Okay, these are the number of tuples for each of these tables. Say that and you want to increase the scale now, right? This is just a 1 GB representation. Now what we can use is using this chord, say we select certain relations to increase the size for. And we use this scaling option now, and in terms of size, and you can give, so I think the scale factor is very, very high, okay. I think it's 10 power 6 or 10 power 7. And you can ask it to scale it. So what it has achieved is, now you will see that essentially this whole tables, now we can see the metadata is actually scaled is successful, okay. And now you will go back and check whether it has actually scaled it or not. Now you will give the same query, so these were the number of rows before, and if you give the same query, now what you will see is it has increased from now to 10 power 13 rows. So this is the, so you have actually changed the statistics, right, using the chord software. So what? So I kept on saying that we can test big data using small testing, right? So we have changed the metadata. Now let us see what we actually found in practice. So this is a real use case that I am talking of. This is application of chord software. So what we actually found is that, and in a commercial engine, okay, I'm not going to say the name of the DBMS software because some of your uncles could be working there and they'll probably sue me, right? So here what we actually saw is that, see, we know that, see, this represents the time taken to for each query as the number of tuples increases, which means that consider a scenario where we have the salary predicate, right? So if more tuples pass through the salary predicate, the more time it will take, right, naturally. And this represents the more sort of the more cardinality that will pass through the predicate. Since you have to process more, the time also should increase. That is represented by the y-axis. What we actually saw is, after a certain point of time, the optimizer said that it will take lesser time. So which is wrong, right? So that is unusual behavior that we saw at very, very big data, and that was helpful only using the chord software. And another nice bug that we found actually in one of the popular database, commercial database system is that we found that there is a 10 power 18 constant that has been hard coded in that system. You actually can see that here is that when you scale the data, so it said that you cannot process more than 10 power 18. So some developer had put a 10 power 18 hard-coded constant, say that we could not imagine that, I mean, no data will be more than 10 power 18 ever, right? And so that bug we actually found out and told to the commercial engine people, to the appropriate company. And so these are the sort of bug that we found out using this software, and these are real-time bugs that we actually, industry also gets help from. And this software is actually used by most of the commercial engines like Oracle, HP, and so on. And we actually also interact with them. And so the takeaway is you can actually test big data without having data. And yeah, all the big data scenarios you can test. Thank you. So any questions?
Not, then let's thank Srinivas. Okay, thank you.
Yeah, thank you.
So